In this video, I will present you our tool called DeepCrime, which is created for mutation testing of deep learning or shortly DL systems, and that is based on real faults. Existing DL mutation tools represent post-training operators, which mean that these operators are applied to an already trained and saved model by usually tweaking the weights in the random manner or adding or deleting some layers of the model. This setup is not very realistic, and thus we decided to propose our own mutation operators and implement them in a tool called DeepCrime. So we propose pre-training mutation operators that imitate real faults that occur during the L development and that target training data, network structure, or hyperparameters before the training. To come up with these operators, we systematically analyzed existing classifications and taxonomies of DL faults. We proposed 35 mutation operators and 24 of them were implemented in our tool. Here you can see these operators grouped by the area application with the corresponding numbers of proposed and implemented in the brackets operators. Almost all of our operators are parameterized, which means that we can create different configurations of the same operators. To account for the statistic nature of DL systems, we adopt statistical notion of mutation killing, where we train n samples of the original and n samples of the mutation model, collect their performance metric, and rely on a statistical test to decide whether the difference between two sets of values is statistically significant and thus the mutant is killed. Lastly, to avoid the problem of equivalent mutants, the mutation score of a test set is measured with regards to the training set. In other words, we measure how many mutants a test set kills from those killed by both the train set and the test set. The total mutation score of a test set is calculated as the average across the mutation scores of all the other operators. Now I will show you the tool itself. Here you can see the structure of our tool. There are folders where we store the sources of the models under test, the mutated models, and the trained models. Then we have the sources of the tool itself and the list of the project dependencies. We also have the README file with all the detailed instructions. Now I will show you the list of the changes to be done to a model to prepare it for testing. The evaluation of the model should be enclosed in a function called main, and this function should return the evaluation score of the model. Then we have a couple of lines to save the trained models or to load them for the evaluation. There are also a number of files important for the users where they can set various parameters such as the number of the retraining for statistical test or the parameters of mutation operators. Finally, there is a launching script of the tool where the users need to specify the subject name for the model and then the path to the model sources. Now I will show you a quick example of the usage of our tool. So for the ease of the presentation, we'll show the example in Google Colab. The first step would be to clone the repository of the tool from the GitHub. It was already done and you can see the familiar structure on the left. Then if you set up the tool on your local machine, you would also need to install all the dependencies from the requirements file. Here we can skip this step and then proceed to the setting Python paths and going to the folder with the tool. Then once your model is prepared for the testing and is placed in the test models folder of the tool, we can launch the main script of the tool by executing python run deepcrime.py. Once executed, the script will take your model, create its mutated variants, and then it will train n instances of the original model and n instances of all the mutants created. This would allow statistical mutation killing. Then it will evaluate all of the trained models on both training dataset and the test dataset. And then it will calculate the mutation scores and finish the execution. The output of the tool is saved in the set of ICSE files. So here you can see that for each test model, we have a file where the performance metric of the all original model instances are saved. Then we have a CSV file with the performance metric of all the instances for each of the created mutants. Then we have a file for each mutation operator where we specify for each its configuration whether it was statistically killed or not. And finally we have a CSV file where we store the mutation score. So we have a mutation score of the test set for each the mutation operator, and then we have a total mutation score of the test set. So this was the short demonstration, and all the details can be found in the README file of our tool, and also we can find the link to this collab example there if you want to try it yourself. Thank you for the attention.